Today we're going to teach 3-5 coordinates in three-dimensional. There are some great pictures of what some three-dimensional planes look like in your textbook on page 214 if you'd like to first look at what those graphs look like. We're going to just do some point plotting of three-dimensional points, and I highly recommend you write down the shape of this graph. You'll notice the x kind of goes down in front, the y goes off to the right, and then the third dimension, z, goes up. The octants become very important. I would highly recommend you write down the front back is for the first axes, that's the x-axis that you graph first. The right to left is the second thing you graph, and that is the y-axis. And then the third axis, which is the z-axis, is top to bottom. I'll give you a little bit of time to write down those items. All right, let's graph our first example. We want to graph one point on a three-dimensional plane. The point that we're going to graph is point A. It is 2, 3, negative 2. Think of the 2 is your x-axis where you're going to move. And then the blue is your y-axis. And then your green is going to be your z-axis. And I did type up the movements so you can kind of see how it works. Remember back to that first slide, depending on if it's a positive or a negative. So if we look at this first slide again, we're working on these octants right here. Notice the first one is going to move us front or back. Since it's a positive 2, we're going to move to the front. So we're going to go along the x-axis, and we're going to go to the front 2 places. So just about there. So here's 1 and 2. Then we're going to go right or left, depending if it's a positive or negative. In this case, it's a positive 3. So we're going to move to the right along the y 3 units. So 1, 2, 3. So now our point so far is going down 3, or down front 2, and then right 3. So we're right here so far. And then we're going to go move down 2 units on the z-axis. So notice our z-axis is right here. If it was a negative, a positive 2, then we would go to the top. So we're going to go down 2 units on the z-axis. So imagine this z-axis going straight down. So if you see this black line, kind of continues down, and we're going to go down 2 units. So here's my blue, I'm going to go down 2 units. So there is my official point A on my graph. Second example, we're going to graph point B. Point B has the value negative 1, positive 1, positive 2. So I have the directions on how you're going to graph it on the smartboard. So let's start with negative 1. So we're going to go along the x-axis. So that's the one we move front or back. In this case, we're going to go backwards. So imagine this x-axis going straight backwards. So if you think of this as positive, positive, this would be negative, negative. So we are going to be right here so far. Then we go along the y-axis. Next, it's a positive 1. So we're going to go along the y-axis 1 unit. So if we think of this as 1 unit, we're going to move to the right 1 place. So now it's right here. The last step is to move 2 units up, since it's a positive 2 on the z-axis. So here's our z-axis, and here's our, so from that point, here would be like 1, 2, 3. We're going to start here now and go up 2 units. And here is now our official point B. For a test or quiz, we're not going to actually ask you to graph these. We're going to be looking for the directions. Tell me where to move this point. Because three-dimensional graphs get to be a little difficult because you have these lines that kind of go in 3 different ways. So we're looking for, can you tell me if I give you this point, negative 1, 1, 2, tell me where it moves. And you're looking at front and back, right and left, top and bottom. Last example. We're going to graph a point C. So here is your x-axis, and so this case is a negative 3. So we're going to go back along the x-axis 3 units. So imagine this would be a positive direction, 1, 2, 3. But we have to go backwards along the x-axis. So we would continue this line, and we'd go 1, 2, 3. So now we're about there. Now we're going to go and move to the left 3 units because it's a negative 3 on the y-axis. So there's 1, 2, 3. So we're going to move 3 units to the left. And then we're not going to move it all uh-oh, we went the wrong way. 3 units to the left would be this direction. So imagine continuing this y-axis in the negative direction, 1, 2, 3. This would be a positive 3, so our movement from here, we'd start here now and go 1, 2, 3. And that's where our final point would be because our z-axis is a value of 0. So you don't move that point. So there is our final point for point C. All right, again, you don't have to graph these on a test, but you do have to tell me what the movements are. All right, here's some more examples in case we needed them. This is what we call isometric graphing, where you can graph in 3D. I'm just going to show you what it looks like. So here would be, let's say, your y-axis or your z-axis. Then you have your x-axis. And then your y-axis. And then you would graph some ordered pairs there. We're going to just stick to these styles of graphs for us. The last concept of this lesson is where we find out what are the 3 intercepts, where they touch on the x-axis, where they touch on the y-axis, and where they touch on the z-axis. So it's kind of like when we think of when we graph x-intercepts and we want to find the x-intercept, we set y equal to 0 and solve for x. If we want to find the y-intercept, we do the opposite. We let x equal 0 and solve for y. So we're going to do the same thing here in this problem. So here's a three-dimensional equation, 3x plus 4y plus 2z equals 12. I recommend that you write this problem down and work it through with me. So let's work on step 1, finding the intercepts. To find the x-intercept, we're going to let the two variables we're not working with, y and z, and we're going to set them equal to 0. So notice, here is our y, here is our z. Those two terms will always cancel out. So we have 3x, 4 times 0 is 0, 2 times 0 is 0, and then 12. So our equation now looks like 3x equals 12. So then we just solve that equation for x. So we divide both sides by 3. So x equals 4. So if we think about where it touches on the x-axis, is that x equals 4. It's a positive 4, so in that case it's going to move to the front 4 units. We're not going to have you graph all 3x, y, and z intercepts. We just want you in this lesson to find out what they are. And that's the same thing when we take a test. All right, let's find the y-intercept. So now we're going to let x and z, the two we're not working with, equal to 0, and we're going to solve for y. So it's essentially like hiding the x and the z term, removing them and just focusing on the y term and then the constant. So this becomes 0. We have 4y. That becomes 0. And then we have 12. So our equation now then is 4y equals 12. Then we divide both sides by 4, and y equals 3. So that is our y-intercept in our three-dimensional shape. It touches on the y-axis at 3. So in this case, it's a positive 3. We would move to the right 3 units, and that would be our ordered pair for that. Our last one is to find the z-intercept. Where does it touch on the z-axis? So now we're going to let x and y be 0. So the x and y terms will cancel out. They will become zeros. And then we will be left with 2z equals 12. And then we solve this equation for z. Oops. That should be z equals. So on your z-axis, it's a positive 6. So we are going to go up 6 units on the z-axis. Your homework for 3.5 is from problems 2 through 8 on page 216.